Okay, so what we're going to do today is we're going to start learning how to do a stoichiometry problem. Stoichiometry starts with a couple of steps. The number one step is to write a balanced equation. After this point, this is where my instructions are going to shift from what other teachers would tell you. So what I'm going to tell you now is using the tools that I give you, this is how you can do it. Pardon? The paper for today is right there. But that's not what that's going to be set aside. That's for homework today. The people that are watching this video, the homework is actually linked on the daily slide agenda. It's in Canvas. So most people, after writing a balanced equation, will tell you to do a mole conversion into moles. I don't do that. What I tell you to do is step 2 is to plot where you're going to begin on the known side of our mole island. So number 2, plot where you start on the Stoich map. And this will be on the known side. So when I'm saying known and unknown in stoichiometry, this is what I mean. When you're given a problem, they're always going to have a balanced chemical equation to do anything stoichiometry because that's where we get our relationships from. When I say plot where you start on the Stoich map, the known side, the known side is in the question. They're going to have to give you a number of something. Whatever one that they give you a value, that is your known substance. Okay. Number 3 is going to tell you to plot where you finish. If you plot where you finish on the Stoich map, you're going to end up in your unknown. So, what is the finish? What is this unknown? What the unknown or finish thing is they're going to, when they ask you in the question, how many grams of this or how many moles of this, anytime you have a problem, you're going to have a start, which is what they give you. You're going to have a finish, which is what they're asking for. So the start, the one that they give you a value for, we know that value. That's the one we know how much we have. The other substance is what we don't know how much we have. This relationship goes across the whole thing. Okay? It goes across where I'm going to say I have a known value of one substance. I have an unknown value of another substance. What is that unknown value? And it's based on the relationship of the coefficients. It could be I have this much of this reactant. How much of this reactant will I need to use to completely use this up? Or I have this much of this reactant. How much of this product can I make? It can go either way. Or I have this much product. How much of this reactant did I have to react to make that much product? So this relationship is not a one-way street. The relationship in this recipe is a ratio between every single component, but we're only going to deal with 2 of them. So when you're doing like a BCA chart and you see that we're talking about the relationship between the reactants and only one of the products, but it has 3 products, do you have to write all 3 products on your BCA chart? No, you do not, because you're only talking about the relationship between those 2 reactants in that one product. Does that make sense, everybody? In a regular stoichiometry problem, we're not even looking at anything more than 2 products at any given time, or two parts of this reaction. It can't be more than 2 parts of the reaction because I can't show 2 different relationships in the same equation. Does that make sense, everybody? All right, so the last thing is, or the number 4 step is, choose the path with the least number of steps. Okay? If you go upstairs during the morning help in 272 to get help, or you go to the assisted study hall and get help from those teachers, not every teacher teaches the way I do. And a lot of them will make you go 2 moles and then cross over. But when you look at your mole island here, if I start here and I end, let's see, here, if you do it the way they're telling you, let me move this up. If I start here and finish here, if you do it the way that a lot of them do for general, they would have you go from liters to moles, which is divided by the 22.4 liters. Then you cross over from your known to your unknown using the coefficients, and then you go from moles to liters by multiplying by 22.4 liters. What's the point of dividing by 22.4 liters and multiplying by 22.4 liters in the same set of equations? It doesn't make sense. If both substances are a gas, you can just use the coefficients to represent liters. You don't have to go to moles to do that crossover. Okay? Just put the coefficient in, and then the unit you would use, instead of saying this this many moles, you would say this many liters. That's all it is.
Wait, so if you have a certain like STP for volume of gas,
Okay, yeah, the STP, remember, is just standard temperature and pressure, and we always have to assume we're there to do any of these conversions. So you guys can pretty much ignore the STP at this point. If we were doing gas laws, which we don't do gas laws, you would have to worry about STP, because sometimes you can be doing it at a different temperature. Because who wants to be working at 0 degrees Celsius? So you would use like room temperature, which is standard reporting temperature, which would be at 25 degrees Celsius. Since we're not doing that, you don't have to worry about STP at all. All you have to worry about is the 22.4 liters and whatever the measurement is of moles.
So if we have like 3 liters,
You have 3 liters.
and with a coefficient of 3, that should be 9 liters.
Well, it would look. You'd have to look at. It's not one coefficient, because what you're doing is you're taking the coefficient of the known, coefficient of unknown over the coefficient of known. So this is the one time where you might not have a 1. You're going to have to do 2 steps in this set. So if I have 3 liters here, and I know that I have 3 liters, my coefficient for my unknown is 3, but my coefficient for my known is 2, I would take the 3 times the 3 divided by the 2. Okay? What's that?
3 times 1.5.
3 times 1.5, did you say? I'm sorry, I couldn't. I heard something 3 times something, but I could not hear what you said after that. So you're saying 3 times 1.5 because you just do the math of that. Yeah, it's the same thing mathematically, but not. What I'm trying to get everybody to do is take the number times the coefficient of unknown divided by the coefficient of known, because there are some people who aren't going to see that
Is
relationship.
that only in liters?
No, if I'm crossing over here, the unit's going to be moles, but it's the same thing. If I'm crossing up here, the liter's going to be particles, but it's the same thing. Does that make sense? Did you guys notice where's the only set of ions that you cannot cross over? Mass can't cross over, because each substance has a unique molar mass. So mass can never be represented with a coefficient. Everywhere there's a bridge, that unit can be represented with a coefficient. Does that make sense? Because the ratio is going to be the same no matter what the substance is. The ratio is not the same when we're talking about mass. So I want to do a little problem here so that everybody could work together here. And this one is a hard one. This is like the hardest kind you can get. Okay. The reason why this is hard is both of these are in the unit grams. So we have to find the molar mass for each one of these. Does that make sense, everybody? So What's the molar mass of CO? That's 12.01 plus 16.
So 58.9.
28.01 for this one. You already found this one?
CO?
CO is just 28.01. You're looking at capital C lowercase o, which is cobalt.
Oh,
This is capital C capital O. So it's carbon, which is 12.01, and oxygen, which is 16, so it's 28.01. Pardon? Remember, what's the first step of a stoichiometry problem? You have to have the balanced equation. So I just gave you the balanced equation. You don't have to write it unless you want to write it in your notes for something to refer to, but I'm going to do the work on here. Okay? So this is 28.01 grams per mole. What about this one over here? 3 times 12.01 is going to be 36.03 plus 6.06. So we're at what? 42.09 plus 16. So that's 58.09. Is everybody cool with that? Anybody think I'm wrong? Because I did rush through it in my head, so I could be wrong. All right, so that's in grams per mole. So we're starting in our our Stoich map. We're starting here. We're finishing over here. Everybody see how that works? There's really only one path to take unless you want to add extra steps, which would be crazy ridiculous. No freaking reason to do it. So we're just going to go from mass to moles in our known side. Then we're going to go from from moles of the known to the moles of the unknown. And then we're going to go from moles of the unknown to mass of the unknown. Does that make sense? All right. Doing this in proportions, we would set up 3 sets of proportions. We would start with x mole of C3H6O over the over the 73.6 grams of C3H6O. This is the known because I know how much I have. But I want to know how many moles that is. That's 1 mole of C3H6O over 58.09 grams of C3H6O. So what is 73.6 divided by 58.09? Anybody have a calculator out? Want to calculate that for us? Ben is on it.
What is it?
73.6 divided by 58.09. And remember, this is mass, or we're going into moles now, so we should try to get 3 decimals if we can.
2.66 or 2.67.
3 decimals.
2.669. Or one, wait, hold on. Wait a minute. You already said it.
It shouldn't be 2 because
Yeah, it's 1.2669.
1.267 then.
Yeah.
This is going to be a mole of C3H6O. So at this point, we have moved from here, from our starting point, to moles now. Now we need the next step, the next bridge, is to use our coefficients of unknown over coefficient of known. This is a ratio from the coefficients of a balanced chemical equation. So the next step would be x mole of CO over 1.267 mole of C3H6O. Now, our coefficients are going to be unknown CO is 6. You guys with me so far? So 6 mole of CO over coefficient of known, which is 2. This can be reduced. I'm going to reduce this one because I'm trying to save steps, because I would take this times this divided by this. So if I can reduce this, I do. So that becomes 3 over 1. So now I only have to do one step. So I'm going to take the 1.267 times 3. And what's that going to be? You calculating again for us, Ben? 1.267 times 3.
3.80.
So now we've gone from here to here. We're not to the finish yet. So we have to do one more step. Now we're just doing a mole conversion using the molar mass of the CO. So we're going to say X grams of CO over 3.801 mole of CO is equal to the 28.01 grams of CO, which is the molar mass that we found, over 1 mole of CO. So now we're just going to take the 3.801 times the 28.01. What do we get?
106.466.
Pardon?
106.466.
106.466, you said?
466.
So this would be 47, because this is a mass now. If we're finding grams, we're going to do 2 decimals for that. That's CO. And then it'll tell you to circle your answer. Does that make sense, everybody? Did everybody see how we just did that? We just went from moles of the unknown to grams of the unknown. We're finished. We're at the point where we wanted to end. What's that? It's pretty, if you follow the map, if you do it following this map, at least for the first several problems, until it becomes something that you go, okay, I'm going from here to here to here to here. If you're following this map, it will tell you what to do. And then all of a sudden, you're going to be like, wait a minute. I don't really need to mark anything on my map. I don't need to use any post-it notes on my map. This is something I can see. So I can just set this up without writing anything on the map at all. That's what you're trying to get to. But if you start by following the map, it will show you how to set it up every single time. Does that make sense, everybody? Yes, Aaron.
Are we allowed to use the map, or do we know how to use the map as a test?
Aaron, when we did moles, did I let you use the mole island on every quiz and test?
Yeah.
What do you think I'm going to do here for stoichiometry?
Yeah, we can use it. Well, I'm just asking.
There's no way I would ever do that.
Yeah, we can use it.
Absolutely. You'll have a clean one for a test or quiz. So if you're writing notes on your Stoich map, you're not going to be able to use those because you're going to have a clean version of it. Does that make sense, everybody? Anybody have any questions on this? Yes, Asha. Pardon? That has nothing to do with this. I'm trying to get the recording done right. The next quiz currently is set for next Wednesday. But that's good to have in the video because whoever's at home will know that they should make sure they're paying attention to this because there will be a quiz next Tuesday or next Wednesday. Yes, ma'am.
When you have like the question mark and then grams CO, is that?
This is what the question's asking for. They'll say how many grams of CO can you produce if you use 73.6 grams of this substance?
And then you wrote like the 28.
I just found the molar mass of CO.
So those are the more asking.
Yeah, the ones in the blue down below are the molar mass of each one. Since I see grams on both sides, I know I need to have the molar mass of each one of them. Great question. Allie is on her game today. All right, anybody else? Yes, Anderson. Yes, I was solving for grams of CO specifically because I could have been solving for particles of CO. I could have been going for liters of CO because CO is a gas. I can do CO. The one very, very specific thing I'm going to tell you, you can always cross at moles. You can always cross at particles, but you can only cross at liters if both substances are a gas. I know mathematically it'll still work out, but I want you to remember that it only works if they're both a gas. So technically there is no volume of something else. So I can't just in good conscience say, oh, just go ahead and cross there and do it. No. If it's not a gas, you should not cross that figures because it's not measuring something that's real. Does that make sense, everybody? And the reality is, if I'm going from here to here, it's the same number of steps to go up here and then over as it would be to go here and then up and then over. Okay? The problem that you have is if you're here and they're telling you to go here, do you really want to go down, over, up, or would you rather just go over? That's what I'm trying to get you guys to see. If you follow the map, it'll tell you the steps, and you want to pick the one that has the least number of steps to do. Are there any questions on how to use the Stoich map to set up a stoichiometry problem? Initially, the problems we're going to be doing are just going to be right here. You're just going to go from mole to mole because other teachers write their worksheets up as moles to moles, grams to grams, liters to liters, particles to particles. Reality is if you have this Stoich map, you can do anything to anything at any time as long as you follow this map. Does everybody understand that? Okay. We have a little bit of time left, so why don't we go ahead and let you guys work on today's worksheet. It does say to use BCAs. If you need more BCAs, I do have some more blank BCAs up here. I'll put them right here. Have a wonderful, wonderful time on this. If you need help with it, please give me a yell.